like spatula.
Okay, what you are going to do is you are, to the best of your ability, going to draw and label, without looking, the atomic models from oldest to newest. If you can remember the name, that's great. You can include the name.
Yeah, I remember we did this. I don't remember how to. Yeah, the numbers.
If you were away last day, you can ask your neighbor to help you out with that. And Cachator, maybe you could work with Ryan because he doesn't have a neighbor. Would that be okay? You can do that later. Okay?
Yeah, that's crazy. Really? You learned about stuff. I don't think I would. You're remembering something.
And don't bother looking it up, okay? We're going to go through them all again, but see what you can remember. All right? And like I said, if you were away last day, chat with your neighbor right next to you. They can show you what is up. Okay?
They're right here.
Yeah, and they are right there as well. So draw them, label them, give the name of the model if you can, give the name of the scientist if you can. Just do it to the best of your ability.
I literally just. Well, I saw them and now I can't unsee them.
So far, they all look the same, don't they? So far, all my drawings look the same, except for 5.
How many units do you have?
6.
So are we doing optics?
There's no optics. We're doing electricity for physics this year.
We did optics last year.
Yeah,
And biology?
and biology. So mostly, this is about drawing circles. Mostly. Do we need to add anything to our first drawing? Or is it done?
I'm not sure how to do it, but I know
To the very first one.
the first one.
The very first one.
No.
That's it.
Yeah.
That's a nice, easy one to draw. And by the way, I will never, ever, ever mark you on your drawing skills. Okay? So don't worry. I can't draw, so I don't expect you to be able to make a beautiful circle or anything like that. Okay? Do you guys remember the name of that first model? Billiard ball. The billiard ball model. And who is the guy who came up with that? We only need the last name. Dalton. Okay, so there will be a quiz on this at some point, and you will be expected to give the name and the name of the model and be able to make a labeled drawing. And look, that first one, how nice and easy is that? 3 out of 3, right there. Am I finished with my second one? Or do I need to add something to it? Yeah. I need to add my negatives in because we've got these things here. Each of those little circles inside the big circle is negative. And remember, it does say a labeled drawing. So we should probably label those things. What are those? Those are electrons. What about all the other stuff? Hernan?
Yes.
Not a nucleus yet. We don't get to the nucleus until model 3. Okay? Model 3, we get to the nucleus. Ryan?
I forgot.
That's okay. Don't worry. Emily? Empty space. That's in our next one. Okay? Empty space is in our next one. Yes? It's a positively charged pudding or dough. Okay? Thank you very much. But if you don't like the word pudding because you're like, I don't know what kind of pudding this is, what is this pudding nonsense? You could call it dough if you prefer. If you like the blueberry muffin model of the atom, okay? What's the official name of this model? Plum pudding. So we've got BB billiard ball, and then we've got PP. Oh dear, that sounds not so good. Plum pudding. Anyone remember who came up with the plum pudding model? Not Schrodinger. He's coming later. He'll be in later. Yes. Thomson. And this is weird. Thomson is spelled without a P. It's got a TH. Okay, so we got a TH. Tom. And then there's no P. Very often we have a P in that name. This guy doesn't have one. Thomson. But do I care if you misspell it? No. All right, so if you put a P in there or you forget the H, I'm okay with that. All right. So that one, how many marks would we get for that? We'd get 1, 2, 3, 4. Yeah? Okay. Anything else we need to label in number 3? Marion?
Nucleus?
The nucleus. We need to label the nucleus. Anything else we need to draw? Yeah. Pardon me? Electrons, yeah. And in this model of the atom, they're just kind of hanging out outside the nucleus. So there's that area outside the nucleus, and they're just kind of hanging out. We should add something to the nucleus. What should we add? We should add a plus. Yes. What is this model called? Matthew? Pardon me? Actually, we call it the nuclear model. Okay, but nucleus model, I would probably give you credit for that as well. So this is the nuclear, which is spelled like new and then clear, nuclear model. And who came up with this one? Hudson? Ernest Rutherford, yeah. So Rutherford discovered the nucleus. He said, hey, we don't have a positive dough, we have a nucleus. And on Monday, I think, because you got your test tomorrow, on Monday, we're going to learn how he did that. Okay, so that would be out of 1, 2, 3, 4, probably 5 just for the general diagram. Okay. Number 4. Anything missing from this diagram? Yeah, the electrons. Okay, I'm going to put the electrons on as little dots. There is a specific way to put them, and we're going to learn that later on, okay, but not too later on, soon. If you just put them anywhere for now, that would be okay. But if you are interested, they group themselves. The first shell only has 2. The second shell can only have 8. And the third shell can only have 8. So it goes 2, 8, 8 maximum. But because I've only drawn 3 shells here, I'm only going to put 2 electrons on this outer shell just for fun. Okay, but I could put as many as 8. Okay, and these are electrons. Is there anything else we could label on this? Yes. We could label the nucleus. Yep, and we should give it a positive charge. There's one last thing we could label on here. We could label the shells. Anyone remember the other word for shell? Orbit was the old name for it. We're going to stay away from the word orbit. Yeah? It is energy level, yes. What is the name of this model? That is the Bohr model. And check your spelling. B, what comes next? O. What comes next? H. R. Will you get marks off if you spell it wrong? No. Okay, as long as it looks like Bohr, I'm good. This is the Bohr model. And guess which scientist came up with the Bohr model? It was Bohr. Okay. In our next one, I haven't drawn very much. Not yet. I've got 4 little circles all together. Yes?
I have no idea how to do that last part.
That's okay. I'm going to show you. Okay? These are all clustered together, kind of near where the middle would be. What would that whole thing be? That whole thing would be the nucleus. And I should do something to half of those, or at least a number close to half of them. I should put positives. So I'm going to put positive here. I'm going to put positive here. What about the other ones? Are the other ones positive or negative or neutral? Those other ones are neutral. And because it's going to get really hard to label all the little things, I'm going to put like a little legend over here where I put this and I go, okay, I got my little plus thing. What is that? That is a proton, yes. And how about the little ones with nothing in them? That is a neutron. And then we get to the crazy part. What do electrons do in this model? They go around and they buzz around like little hyperactive flies and they sketch out patterns. Yes? They're like a cloud. Absolutely. They're like a cloud. And the clouds have different shapes, but the one cloud that you can kind of draw is essentially a sphere, but we're only going to draw it as a circle, but it's not going to really be a circle. It's going to be us going crazy, going, woo. You don't have to sing when you do it. But if you want to, I'm good with that. Sometimes I find that when I'm drawing, like I'm not a natural artist. I don't draw things very often, but often when I do, I kind of like sing along with it, which is kind of weird, but there we are. It helps me. All right. What is this thing called? It's called, it can be called an electron cloud. Its official name is an close, not quite orbit, orbital. It's an orbital. And because it's really hard, because we can't really draw the electrons, we're just going to write that it contains electrons. Who is the scientist for this model?
That's Schrodinger.
This is Schrodinger. And the sh, is it just SH? It's SCH, yeah. So we got SCH, shro, and then what's the rest of it? Dinger, ding. Do I still have that? Shro, dinger.
Oh my god, this is from elementary school. This is what they play to make it up.
I used to sometimes. All right, so Schrodinger was the scientist. And what was this model called? We have the quantum mechanical model, yep. Quantum mechanical model. When I was in physics 12, we did quantum mechanics as a unit, and our teacher actually gave us a certificate at the end which said we were certified quantum mechanics, which was kind of fun. It has another name, which is more descriptive. The electron cloud model, yeah. So my thought is that next Tuesday, and I know you're going to be like, what? There's going to be a quiz on this. I don't know, you got a test on Friday, and then you'll have a quiz on Tuesday, but that's okay. This is just a quiz, right? And remember, what can you do with quizzes? Retake them, okay? So if you don't do well, you can do that. So, and there's going to be practice over the weekend to let you, do this. And you've got this now. Yes. I can definitely print this out. How many people would like a printout of this? Everybody. Okay. The other thing is too, if you go into your book on page, let's find it. Not that one. I need 2.1. Look at this. What have we got? This is on page 9. But I will print that out for you as well. Okay, this is on page 9. We've got the billiard ball model, John Dalton, plum pudding, J.J. Thomson, nuclear model, Ernest Rutherford, Bohr model with its shells or energy levels, electrons, and nucleus. And we have the nucleus, the protons, neutrons, and orbitals containing electrons. Yes? So that is there for you. And today, what we're going to do is we're going to take a quick look. We might not get all the way through this today because I want to give you some time to study for your test. And if you have studied all you possibly can for your test, I have some enriched stuff for this next unit that I can give you to take a look at. Okay? All right. So we are now on page 11. Page 11. All right, here we go. You can go back to that if you want to, if you haven't finished yet.
In this video, we're going to talk about how J.J. Thomson discovered the electron in 1897 using the cathode.
Because my computer kept going bing bong in the middle of my grade 12's quiz. Woo, that was exciting. I don't know. Was that from all the way back there? Like springing. Spring loaded, man.
What is that? Hit me?
It's the top half of a pencil.
Oh.
Yeah, and I guess there's, spring in there. All right. Let's see if this is the right sound level.
Ray tube.
Okay, that is, but there we go.
In this video, we're going to talk about how J.J. Thomson discovered the electron in 1897 using the cathode ray tube experiment. So these days, we think about atoms kind of like this. They're made up of a variety of smaller subatomic particles.
And you know what?
But in the late 1800s...
Why is this not attached? Oh, there it is. It is. Okay. Don't worry about filling it in just yet. You can just watch. Does that make sense? So you can get the general sense of it? Okay? Just watch.
It was all about John Dalton's model of the atom. In the early 1800s, John Dalton had proposed that all matter, all stuff, was made up of tiny, indivisible particles called atoms. At first, not many people believed him. But throughout the course of the 1800s, more and more scientists got on board with his idea. But it remained an open question whether the atoms were indivisible. Were they like tiny little billiard balls, hard and solid? Or were they made of smaller things? No one really knew the answer to that. But J.J. Thomson was able to answer part of that question when he discovered the electron. He discovered that it was much smaller than atoms. He discovered that atoms had electrons. And so he was able to say for the first time that atoms weren't totally solid and indivisible, but they were made up of smaller, subatomic particles.
Now, how on earth could he discover these things? They are so small. They are smaller than small. Yeah? So how on earth could he find these? Yeah, if you wanted to cut these up, you could. The size, just take them out from there to get inside them, and then you can cut around them. Sorry, this will just take a second. I don't know where I put my scissors. Oh, you got scissors from before. There we go. So we're going to find out how he came up with this, because he had to be able to do some experiments, right?
Let's look at how he discovered the electron. So Thomson used what's called a cathode ray tube. It's a big tube of glass that's kind of like a bottle. You can imagine it's sort of like this soda bottle. It's sealed all over, and then you pump all the air out of it, okay? And it has these two pieces of metal at this end.
So it's basically a vacuum on the inside. Do you guys know what a vacuum is? Not like but the other type of vacuum where they take out all the air. So this has got this thing. It's got two pieces of metal. One of them has a hole in it. It's a glass tube, but there's no air in there. Nothing, no particles in there other than the two pieces of metal.
So Thomson connected these two pieces of metal to a power source. And here's what happened. A ray shot from this piece of metal across the tube and created a glowing spot over here when it hit a special coating on the inside of the glass.
And it literally is a green, shiny ray. Okay, we'll actually take a little look at a real cathode ray. We don't have one, but we'll watch a little video of a real one.
Now, Thomson didn't know what was going on, but what really was going on is that electrons from this piece of metal were shooting out. They were attracted to this piece of metal, which has an opposite charge, but they were moving so fast that they shot all the way across the length of the tube. Anyway, Thomson sees this ray, and he gets curious as to what it's made of. And so he asks the question, the stuff that the cathode ray is made of, does it have an electrical charge? And here's how he attempts to answer that question.
Because remember, are there any particles in there other than the metal? No. So where is that ray coming from? Has to be coming from the metal, the metal, right? And he's like, well, what's this ray made of? So he's like, well, I know something about positive and negative charges. Do you guys know anything about positive and negative charges? Positive and negative attract. What do positive and positive do? They repel. What do negative and negative do? Repel. Okay, those are some key ideas. So we got positive and positive repel, negative and negative repel. Are you guys going to be good there? What happened?
Like my calculator showing off a bit.
Would you like a new pencil? Here, have a new pencil.
I'm gonna get it. Not be sweet.
Yeah.
Where did it go?
I don't know.
Oh. Thank you. I appreciate it. Shoot my apple.
Okay. So let's see what he does.
He takes two metal plates and puts them on either side of the cathode ray tube. And then he turns on electricity, which makes the top plate positively charged and the bottom plate negatively charged. And check out what happens to the cathode ray. When he turns on the power, he sees that now instead of going straight through, the cathode ray bends up. It bends up towards the positively charged plate.
Think about that. What does that mean about the cathode ray? Tell your partner, what do you think that means? It bends towards the positive plate. It bends away from the negative plate.
No, the ray itself, the green light. The green light itself.
This little green light, it's like, oh, there's positive, it bends towards it, and there's the negative, it bends away from it. What does that tell us about the green ray? It's negative. Thank you so much, that's brilliant. Okay, so that tells us that it's negative. So you guys are, like Thomson came up with this idea, but you guys are coming to the same conclusion as he did. So you guys are like genius scientists. Look at you go. My goodness. Okay.
So based on this, he reasons that the cathode ray must be made of stuff that's negatively charged, since it's attracted to the positively charged piece of metal, and he knows that opposite charges attract. But just because he wants to be very careful, he's a very careful guy, he tries to check this another way. So he uses a magnet. If something has an electrical charge and it's moving, a magnet will push it in particular directions.
And if you're interested in learning how magnets affect charges, because it's a little more complicated than how positive attracts negative and things like that, you would need to take Physics 12. It's very interesting stuff.
He takes a cathode ray tube, if you want to think that this marker is kind of the cathode ray tube, and he surrounds it with a magnet, just like this. We can kind of show what goes on by slipping the magnet under like this. So anyway, he puts the magnet here, and he sees now that the cathode ray bends in the other direction. It now moves downward. Now, if the cathode ray is indeed negatively charged, this is exactly how he would expect it to move in the presence of a magnet like this.
So he's just confirming his results in another way, yeah?
So this is just further confirmation that whatever makes up the cathode ray probably is negatively charged. So he takes the data that he gets from these experiments, and he's able to draw a few important conclusions about cathode rays and what makes up atoms. Okay, So based on the outcomes of the experiments with the charged plates and the magnet, Thomson is able to conclude that cathode rays must be made of stuff that is negatively charged. Okay. He combines the information that he got from the experiments that I just told you about with some other data that he collected. And he's able to come to the conclusion that the particles that make up cathode rays are 1,000 times smaller than a hydrogen atom. Hydrogen atoms are the smallest atoms. So this thing that's in the cathode rays must be really, really tiny.
Okay, and how did he come to the conclusion that they are 1,000 times smaller than a hydrogen atom? He did some other experiments that are too complicated for us to discuss now. They're not, nice and simple like this one, okay?
Compared to an atom. And finally, Thomson swaps out the type of metal that's in the cathode tube.
Maybe he started with copper. Copper's a good choice. And then maybe he swapped it out for, what's another metal? Aluminum. Maybe he swapped it out for aluminum. And then maybe he swapped it out for, what's another metal? Titanium, okay? Or iron, or any of the metals, okay? Nickel.
He uses a variety of different types of metal, but he finds that all of the different metals he uses give off the same cathode rays, and regardless of what metal he uses, the size of the things that are in the cathode rays is exactly the same.
Okay, so no matter what metal, he gets a cathode ray, and the cathode ray behaves in exactly the same way. Exactly the same size, it moves the same way in response to the charge. What does that tell us about all of the metals? This one's a little trickier. Pardon me? The metals do have different structures, but what if what's coming out of them is all this? Yeah. It tells us that whatever's coming out, whatever's in that cathode ray, absolutely correct. It's in everything. Okay, it's not just in one metal. It's not just in this metal or that metal. It's not like they have different things. They all have this thing in them. Yeah? What do we know about this thing so far? We know that it is negative. We know that it is very, 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 very small. And we know that it is in everything. Okay.
So based on these three conclusions, he's able to come up with the idea that atoms have tiny, negatively charged particles inside them. And these things that we're talking about here are electrons. Now, if you're like me when I first learned this, you might be confused how these conclusions definitely tell him that there are electrons inside atoms. I remember when I first learned this stuff, I was thinking like, wait, doesn't this just show that electricity or cathode rays have negatively charged stuff? How does this tell us anything about the atoms?
But you guys already came up with this. So see? Genius scientists.
Okay, here's why. At the time that Thomson does his experiment, everyone, for the most part, agrees that all things are made up of atoms, that atoms are the smallest things that make everything up. They're like the smallest things in the universe. So if Thomson is able to show that there are even tinier things, well, where are those tiny things coming from? They have to be coming from atoms because everything's made of atoms, right? That's the only place they can be coming from. And even if electricity, even if you want to say that, oh, well, he's just showing that electricity is made of electrons, well, then still, where are the electrons coming from that make the electricity? The electrons have to be coming from other atoms. And since he can move and remove these pieces of metal and swap other metals in, and he still gets electrons, it again shows that all different types of atoms are able to release or give off electrons.
Okay, and we're going to pause there because I want to give you guys the last half hour to study for your test. Like I said, if you are done studying for your test, if you're like, oh my gosh, there's nothing left to study, I have done it all already. I do have some enriched stuff for this next unit. Paul, yes. In the review? Well, the review is there for your use, right? So you don't have to do anything, but it's not a bad idea to do so. Yeah? Okay. No, I'm good, but you know what you could do is these go in order. We're gonna replace those ones. And then so number 4. No, I think we can just circulate it. Yes. Is there anyone else who needs coffee?
Why do you guys always like look at each other like that? Oh, the image. I do.
Folks, I'm just gonna go grab the enriched answer sheet and I'll be right back.
I know it's not real gummy. Oh, wait. We did this last year. Very beautiful. Like mine. Mine are kind of good. Taking it, so I know. Oh, oh, it's such a juicy thing.
Is there anyone else who's taken an enriched thing yet? I'll grab you that.
This pen is so nice and sweet. No, that's so good.
No, not yet. Okay.
I'll grab you one. Anyone else want one?
So there's the white book. Yes.
Old Scottish field, let's do. I just like go by it. Right. I'm lying, what the hell is this?
I did not get a sign.
I would even work in my elevator. And I was like, Christmas is closer. When you're the Christmas is I got a little bit. That's fun. And she stood up and yeah. He's like, where is this? Oh, no, no.